Hello everyone. So right now we are back solving the very next problem for it, which is your question number 3, that is given the root of a binary search tree T1 and T2. Check whether the two trees contain the same information or not. The structures of T1 and T2 can be same or different, but understand that binary search trees have a very unique property such that if you do a in order traversal of, let's say, binary search tree, it gives a sorted sequence. Okay, so if that's the case, it sorts it out. So for that we just need a few functions to check it out. First, we are going to do a count function where we have it. Just give me a second, it should be here. Yes. So count function basically checks if whether the two trees have the same number of nodes or not. If it doesn't, it's of course not the same tree. Okay, so that's a very simple thing. So just you call the count, you give the root, and then you just count the number of nodes, and it basically returns the number of nodes that a particular tree has by doing a recursive call of this count nodes sequence, or not function. Okay, and when that's done, we basically store the in order sequence in an array. And how do we do that? We basically do this store in order, that's the name of the function. We give the root node of the tree that we are actually doing the in order sequencing. Then we have an array, and then we have a pointer to the index. Now this is very important because we are going to be using a lot of these functions right now. So see, if the root is equal to null, basically you don't do anything, you just return. Now store in, you do the recursive call to the store in order, and you go to the root left, give the array, give the index. Okay, remember this is a pointer. And then as you go again and do it, you basically just go to the left side. And what happens after that? After you go to the, you do the depth first traversal, then you go to the array and you basically do the point, you do, what do you call this, dereference, yeah, dereference the index, and you basically just store the data inside that array. What we are doing, we are basically doing the depth first. We are going into the depth, then we are storing the value. This is left, this is data, and this is right. Left, data, right. We are doing in order traversal and storing the values in the index. And of course we are actually, after we store the value in that particular array, we also increment the index. So hopefully that is clear. After that becomes clear, we now go to the main function, which checks if the two orders are the same. Basically first we do the counting of the root nodes, and we just check if the nodes are different. They cannot be the same, of course, and both of them are empty, or they have the same info. Then we return a true value. Now so if that is the case, now we allocate the arrays using malloc. We basically do a first array using pointer. We allocate the array based on the size of integers and times the number of the count that we just got. We got the count from the count number of nodes. So number of nodes times the size of integer, that's the total number of memory space or the memory block in the heap that we are going to allocate, and typecast it to int star, basically because it is an array. So we are returning the starting address of the array. We do it for ARR1, ARR2. So we have two arrays. Now if there is some allocation error, we basically return that, okay, some memory allocation has failed or something, and we return a 0. After that we do the in order traversal. So we first start with index 1 and index 2 as set to 0, and we basically do the call of in order, like store in order 1 and store in order 2 to get the two arrays. And basically they, where is it, yeah, it is here. So basically, oh, by the way, you might ask, okay, this is fine, with why are we using this star index pointer? Because remember, we are passing it by reference, not passing it by value. If we were passing it by value, we need to have some kind of global index that we don't want to have. Okay, so if that's clear, now what we need to do is, after the in order traversal, we basically just check whether those two are same or not. Initially we assume that both of them are same, That is, this is basically a Boolean flag, and what we do is we just do the traversal of the two arrays and we return 0 at the point where they are not the same. And after all this is done, we basically free the arrays and return the result, which can be 1 or 0, based on the whether the two binary trees or the binary search trees better to are they the same or not. Now remember that there is one more thing, that is the compare integers. This was particularly, we wanted to use it in 3 and 7, but we never used it in 3, but we are going to be using it in 7. So now that it is done, you can just go ahead and look at the logic and check it whether whether the two binary search trees have the same information or not. Okay, and yeah, this is the logic. Basically, you first is the count nodes logic. Next is to allocate the two arrays, and of course the size must be equal to the number of nodes that each binary search tree has, which is the same after the count nodes kind of couldn't like filter out the differences. So then we compare and we return, and this is the logic behind this. Okay, so with that being said, that was the solution to the third problem. Thank you, and let's see you on the fourth problem.